Okay. Properties of systems of linear equations. All right. So we've talked about systems. We've talked about solving systems graphically, solving systems by substitution, solving systems using elimination. And now we're going to talk about just some general properties of these systems, okay? There's only three main categories that the systems of equations could fall into. And I think we've talked about this near the beginning of the chapter, actually. I think we've actually talked about this. So this should be not brand new. Okay, from your textbook, page, I don't know what page this is on now, 442, okay? Here's an example of one system of linear equations right here. X plus y equals -3, and -2x plus y equals 3, okay? So the solution comes from the intersection point of the lines, right? So the intersection point, if you were to do this on a graphing technology, the screen might look like this. So x equals -2, so you look 0, you go 1, 2, and y is -1, 1 down. That's the point. Therefore, the solution is x equals -2, y equals -1, okay? That should be, everyone should go, yeah, I know that. I've seen that before. That looks good. I understand, okay? Now, there's one solution here. There is another option for the lines to be at different slopes, okay? And what happens if the lines are at different slopes? You could end up with situation number 2. Now, if you look at this system right here, you might not know at first, you might not realize it right away, but if you were to graph these lines, and they're graphed below, they are parallel, okay? That means that their slopes are exactly the same. And so if you have slopes that are exactly the same, the lines kind of come like this, and then they are parallel. Therefore, parallel means that they are always the same distance apart. They never get closer or further away from each other, and so they will never intersect. If the slopes are identical, okay, the slopes have to be identical. If they're really close, okay, like if you have y equals 0.049 x plus 1, and you have y equals 0.048 x minus 5, these are different. They're very, very, very close. They're only 1,000th of a unit different. But because they're different, that means that eventually, way in the future, way off the graph, they will meet somewhere, okay? They have to be exactly identical. In this case, if they were exactly identical slopes, they would intersect, or they wouldn't intersect. Now, the third situation comes when we look at the y-intercepts, okay? Notice these are different. The y-intercepts have to be different for the lines to be parallel. What happens if it just occurs that the slopes are the same and the y-intercepts are the same? Well, then we have something that looks like this, where they're actually the same line. If they have the same slope and the same y-intercept, they are the exact same line. That's the third and final category, okay? So again, you look at this and you wouldn't notice maybe right away that they have the same slope and the same y-intercept. But if you could figure that out, then you would know a lot about the system. In this case, and I think I've mentioned this, nod your head if I've mentioned this early in the chapter about the lines being the same lines. No? I didn't talk to you about this? Here's the thing, I teach a bunch of math classes, and we've talked about systems in my other math classes too, so I've talked about all this. I talk about this every day, okay? So I don't know if I've mentioned this to you or not. But if they have the same slope and the same y-intercept, that means they are the exact same line. So since the graphs coincide, and when you should know that word, coincide. If something coincides, that means they are the same, they're coincident. On every point, that's the one line is exactly mapped on top of the other line. Then the solutions, okay, is not just 1 point or 0 points, but the solutions are all points on the lines. So if the solutions are every point on the line, you remember that lines keep going forever, right, in these directions. And so that means that there's an infinite number of solutions. Okay? So if, if something is identical to itself, that means it's identical in every conceivable way, right? The number 2 is the same as the number 2 in every conceivable way, like in an infinite number of ways, okay? 2x equals 2 is only the same when x equals 1, right? But 2 equals 2 is the exact same in every conceivable way. So if you have two things that are identical to each other, there's an infinite number of solutions to them being the same. Okay, so 3 categories. Once again, first one, different slopes. Okay, so you can maybe start writing some notes if you haven't yet. Okay, so system 1 or category 1, let's put category. So category 1 is when, and the most important thing here is the slopes are different. Oh, what am I going to do? Slopes of the lines are different. That is really the only thing that matters. If the slopes are different, then you have one intersection point somewhere. That's the only thing you look for. It doesn't matter about the y-intercepts. Are they the same or different? Doesn't matter. Okay? If the y-intercepts are the same, but the slopes are different, look at what happens to this line. Let's say that both lines have this y-intercept. Well, that means if this slope doesn't change, that means that line just moves up, right? And they have the same y-intercept. Well, big whoop-de-doo. They still have one intersection point. It just happens to be on the y-axis then. That's all that means. So it doesn't matter about the y-intercept. If the slopes are different, it's category 1, one solution. Okay? Slopes are different, one intersection point, so one set of solutions. Okay? 1 point, one value. I'm going to write this as messy as I can for x, and one value for y. Okay, is that pretty messy? You like that? Is it better than your writing? Yeah, probably is. Yeah, wow. That's right. I can't even imitate your writing. Like I literally, if I wrote with my left hand with my eyes closed, then maybe. Okay, you know what? I have to try. Okay, all right. So ready? I'm trying to imitate your writing. Are you ready? Let's see. I'm gonna get a start point. Okay, are you ready? Left hand, eyes closed. Okay, one value for x, one value for y. Yeah, that's like your writing, right? Okay, cool. I can do it. Okay.
It looks like shorthand, like doctor.
It looks totally cool, doesn't it? It looks like I've got some Riz.
Oh yeah. Can I get a math?
Rizzy might have nice writing.
Did you guys just puke a little when I did that? Too bad. Yeah, someone just gagged.
I'm not saying he doesn't have Riz. I'm saying.
You know what? You guys just need to grow up. Okay, category 2 then. As I mentioned, okay, I won't do any more cool things to make them uncool or to make you throw up a little bit in your mouth, okay? I'll try not to anyways. All right, category 2. Category 2 is when the lines are parallel, okay? Now, what you're looking for in category 2, when there's no solutions at all, there's none, no solutions, they never meet. You're looking for the exact same slope, but what? Different, what did I say? Different y-intercepts. All right? So, category 2, there's no intersection, so there's no solution, category 2. Why? Because the slopes of the lines are equal, and I'm going to have to add to this, the y-intercepts are different. They have to be different for category 2. Okay? That is, slopes are the same, so they're parallel, but different y-intercepts because they can't be the same line, because that's category 3. So category 2, lines are parallel, there's no solutions, and you find that out when you notice that the slopes are the same but the y-intercepts are different. And we're going to get practice identifying the systems. Right now, I just want to explain what the categories are. Okay? Capiche? Yes? Okay? It's totally awesome. Oh, sorry, I wasn't going to do any more things that make you gag.
Yeah, exactly.
Okay, here's category 3. Category, unless you're a dog person, we can call it dogatory. Dogatory. It sounds like,
It's like an asylum.
yeah, it sounds like it's like a bad place.
Dogs with rabies.
You're going to dogatory.
Dogs are better.
Yes, this is recording. I'll edit all this out, don't worry. Listen, child of mine, quiet over there.
No, when I'm older, I'm gonna
Time to be quiet. Order in the court. Order in the court. Order in the court, please.
Oh, okay. Oh.
You guys are so slow. That's a joke.
Yeah.
Do you get that?
Odor.
This lesson is quickly devolving. It's descending down to dogatory.
What?
All right. Category 3. You guys listening now? Category 3. This is when the lines are actually the same. Now, they don't look the same. Okay, they're in different form, but notice that one line here is just double the other line. See, if you multiply everything by 2, you don't change the line, you just change how it looks. So if you notice here, 2x becomes 4x, y becomes 2y, negative 1 becomes negative 2. This is all just doubled. And when you have two lines where one is just a multiple of the other, like it's just multiplied by a constant number, it's actually the same line. Okay, so category 3 is when one line is exactly the same as the other line in the system. They have the same slope and the same y-intercept. Okay, and again, we're going to identify these systems or these categories by examining the slope and the y-intercept. All right, and that'll have to be maybe part 2. This is just an introduction. We're going to run out of time shortly, but I'll go until the bell. So category 3, the lines have the same slope and same y-intercept, or I'll maybe just type this out as well, like I mentioned. One line is a constant multiple of the other line. And that's fancy terms for one equation is just multiplied by a constant number to get the other one. If that's the case, if all the terms are just multiplied by a 2 or a 1/2 or a 7 to get the other one, then you know they're the exact same line. Okay, so how do we identify each of these categories? It's actually pretty easy. You want to, and we've done this already, you want to change the equations into y equals mx plus b. Okay? So how do we identify? Change to slope y-intercept form. And simply examine the slope and the y-intercept. That's how you do it. So let's do number 8 together really quick before the bell rings. I think, what are we at? Yeah, bell's gonna ring soon, shoot. Okay, let's do the first one, and then that'll be good. So this one we're gonna change into y equals. So I'm gonna get the x to the other side. Guess what? This is gonna be y equals negative x minus 2. Awesome. I'm going to isolate for y, so I'm going to get this x term to the other side. That's going to be negative 2y equals 2x plus 4. Divide by negative 2, right? Everything. So I'm going to have y equals negative 1x minus 2. Look at this. I've changed this over, and they are exactly the same, aren't they? So how many solutions does this first one have? Because they're the exact same slope with the exact same y-intercept, infinite number. Okay, good. Let's do C real quick. C. I'm not going to erase it. Y equals, okay, I'm going to do this faster. 3x is going to go over there. Negative 3x minus 1. Okay, that's the first one. The second one, Negative 2y equals, this is going to be positive 6x plus 12 when I get this over. And then divide by negative 2, I'm going to have negative 2, that's negative 3x minus 6. Okay, so I have these are my 2 now, negative 3x minus 6. Okay, so if I look at those now, I can see that the slopes are the same, right? And the y-intercepts are different. So which category is that? Category 2, how many solutions? No solutions! Woo! Okay, now over here, if I quickly do B, I might find that the slopes are different. If the slopes are different, boom, that's all you need to check. And you know it's category 1, there's 1 solution. Okay? So let's do B real quick. The bell hasn't rang yet. Oh no! Bell. Fine. Bye.
Bye. Love you. Have
Okay, everyone say goodbye. Okay.
Jesus loves you.
Here's your homework. Mr. Math, yeah, check out MrMathRiz.com. Oh yeah, like and subscribe and hit the bell for notifications. Okay. Hey. Hey.
It was Jedediah.
Jed. Hey.
Can I?